Good afternoon, everyone, and welcome to our first week of the webinar series on AI in food and health. My name is Yamine. I am assistant professor within the Wageningen University Information Technology Group, and I am happy to host today's session. Thanks really for joining us. Let's begin then. Our first speaker is Dr. Hans Marvin. He's leading expert in digital innovation and food safety. Today, he will share insights on how digital tools are transforming the way we approach food safety and how these technologies can support faster and more reliable decision-making. He currently works as a senior scientist and Haring Group, where he applies AI and big data technologies to deliver high-quality services to the food industry. Hans, thank you for joining us. The floor is yours. Please feel free to share your slides.
Thank you very much, Yamine. I will try to share. I guess if everything works, you should now. This one was difficult indeed, just to get it full size. Yeah, now it should be full size, right?
Yes.
Okay, then I can start. Thank you very much, Yamine, for your nice introduction, and also for the opportunity you have given me to discuss with you some developments within the digital tool implementation across the food safety landscape. Which is based on only some highlights I would like to address, which I think are important, and also in which I have been involved. But also, I hope I can help you to trigger your fantasy for future work. I will start with an introduction to explain why I have specific interest in this application of AI in food safety. Then I will come with some examples of machine learning and food safety, specifically focusing on Bayesian network in the implementation of the system approach. And I will try to explain why I think this is a very attractive way of dealing with this. Then, because data sharing is always challenging, I would like to discuss briefly with you the use of federated learning, and I will use the Bayesian network for food fraud prediction as an example, and I will end with some conclusions. This graph basically shows you the supply chain going from the farm to the consumers, from the left to the right, and the logistics and food processing in between. There are many actors and many steps in the supply chain. I mean, I know I have a farmer, but it can also be vessels for marine farming. There are many drivers. On the top, you see many drivers that have a direct or indirect effect in the performances of the food supply chain. Drivers such as science and technology, the industry and trade, environmental energy, and so on, and governments. All of these drivers that have an impact directly or indirectly. Also, data is generated and collected by many different companies and authorities throughout the world. Besides that, also food safety data is collected throughout the supply chain by the different actors operating in the food supply. So in summary, in this slide shows you the different ways to collect data on food safety or related to food safety. Of course, the first one is the hazard-based monitoring programs performed by authorities and industries where food safety at the presence of food hazards or hazards in the food is monitored. But there are also developments and also publications where the different digital devices are implemented in the food supply chain, such as wireless sensor networks, And for example, there are examples in the meat and the dairy sector where these kind of sensors have been implemented in order to monitor or collect data related to quality, but also to food safety. Also, biosensors or computer visions are already being described in literature. These digital devices and the monitoring programs on hazards are structured data. You know exactly what you collect because these methodologies have been designed to that. But besides that, there are also unstructured data that is available and collected by different actors, such as text from websites, blogs, scientific literature, and social media. And nowadays, you see the last couple of years, natural language processing is also a new data source that generate new data that can be used for food safety control. And of course, the implementation of blockchain in several cases have been published and where the traceability and transparency is objective. So in summary, there are a large amount of food safety related data that is being generated and collected, but it is scattered all over the internet and can be structured, unstructured, and it is stored in many different types of formats. Obviously, if these are open source and available, it is interesting to see whether you can use this data for predicting or preventing food safety risks. And machine learning technologies can help you to retrieve these kind of data and also use that data for the analysis to generate new knowledge or to develop prediction models so that you can predict potentially food safety risks in the future. Promising in this regard is the Bayesian network approach, where, especially in relation to the implementation of a system approach. And I would like to give you an example how that works. You see nowadays more and more publication, especially from Chinese research groups, where this Bayesian network is used and for the development of, say, successful prediction tools. The first, the system approach. What is it? As I mentioned in the previous slides, there are a lot of data collected from drivers that have an impact on the food safety development in a food supply chain, such as economic, politics, and so on. We were looking at when you want to develop a system approach and use all of that information, you need a method, a machine learning method, AI, that can utilize this kind of information. So there are some characteristics that the method should comply or could work with. And I showed a couple of bullet points here of which methods should be able to use. It should be first be able to integrate expert knowledge and data. So because there's a lot of knowledge throughout the supply chain on those who are really on the ground that have a lot of knowledge, but that is not always implemented in the models. The models that should be used for a system approach should also be able to handle huge amount of data and also data gaps, because for many factors, not all the data is available. Some methods need default settings in order to run, and when there are a lot of data gaps, that means you have to fill in a lot of defaults, which will influence the performance and let's say the accuracy of the model, which you don't want. Besides that, this model should be able to use a variety of data sources of diverse nature, and preferably also be able to make a scenario analysis, because you would like to see future scenarios and to see whether that impacts and to which extent it impacts the presence of food safety on your product. Since so many actors are generating data all the time, you don't want a static model. You want to have a model that easily can be updated with new data. So testing a lot of um, uh, AI models and approaches, Bayes' network came out as the approach that can deal with these requirements that are mentioned here. And I would like there are many different types of studies now published using Bayesian network, and I would like to demonstrate what can be done. I have one example from a publication of Busenbrock and myself in 2019, where we developed a prediction model on food safety hazards, any food safety hazard, chemical or biological, but also even fraud that appears on any fruit and vegetable product imported to Europe from Turkey and India. In this approach, Bayes' network was applied, and the data from climate factors, temperature, precipitation, agriculture factors, and economic factors were taken into account. Integrating all that information was integrated. Here on this slide, it shows you, let's say, the difficulties in relation to the data gaps. On the right side, you see all the factors that were integrated in the model, which on the top there are these agricultural parameters, maximum residue ratio, herbicides, insecticides, fertilizer use, and then there are agricultural values as well, going down, climate factors, and then economic factors as well. So on the right, on the bar, you can see in total we had more than 3,500 number of cases. These are contaminants on food and on fruit and vegetables from these two countries appearing in the rapid alert of food and feed at any time. So as you can see, the bars are not all the same. So there are shorter ones. So the production and sowing area, sometimes we only had around 2,300 data cases. So it means there are a lot of data gaps here in this model. And with all these data and these data gaps, the Bayes network was generated and also published. So on the right, you see this graph. It's a typical Bayes network model where these spherical ellipses is each factor with different colors. The green ones are agriculture ones, and the yellow one are the climate factors, and the other ones are agricultural. The light one are agricultural factors. In the center, you can see the hazard category. So this model was optimized for the prediction of the hazard category of any fruit and vegetable imported at any time from Turkey or India. So the model has an accuracy of prediction more than 95%, which is quite good. So this means also, and of course, this Bayes network was modeled based on historical data, but it has shown that this Bayes network remains high prediction accuracy also for future contaminations, which can be tested after the model has been developed and the data is not within the Bayes network model. Which I told you, scenario analysis is very attractive because then you can assume a specific change in one of these parameters, let's say the climate, assuming that next year the forecast of the maximum temperature will be 2 degrees higher. Then you can fill in that assumption in the parameter, and then directly see the impact of that change in the prediction of the hazard category, which hazard it will be, but also the impact on other parameters. So because everything is interconnected. And in the study, which has been published, a lot of these scenarios were tested, and I only have taken out a couple of them, which are which are highlighted here. So in the center, you can see the main hazard categories influenced by the climate factors were mycotoxins and pesticides. The other hazard categories were much less affected, which we would expect because of these scientific publications and what we know about mycotoxins and pesticides. So you know that the climate factors are there. Then also the two most effective factors influencing the mycotoxins contamination were the mean temperature and the minimum temperature. And if we look at the pesticide, the precipitation and the minimum temperature, these were the most dominant factors for affecting the pesticides. So this was the outcome of that study. Now I would like to discuss with you the federal learning framework and with example of Benja's network of food fraud prediction. The models the model what I showed you was based on open source data, public available data. Although very scattered, so there's a lot of time that you need to find them, the data, and integrate it. The food safety data came from national programs and also Rapid Alert of Food and Feed. But of course, a lot of other data is collected, or other food safety data, or in this case, food fraud data, is also collected by actors, by companies and other actors in the food supply chain, which is not available. In fact, which are difficult to share. And now deferred learning can help you in such a situation. And we only demonstrated for food fraud, for predicting the food fraud type, but of course, any other topic, the one that I just showed you on fruits and vegetables is also possible. Here to the left, you see a graph where on top you can see station 1, and then on the bottom station 2 and station 3. Each station 1, represents a data owner who has specific information, specific data on food fraud. And station 2 and station 3 also has the same information. Because these actors don't want to share the data in the sense giving the data to someone else. They want to sit on it because they have either paid a lot of money to generate it, or it is sensitive. But nevertheless, they use this Bayesian network for the prediction of the food fraud. Yeah? So all of these three data owners, they are interested in a Bayesian network for the prediction of food fraud, but don't want to share it with other ones because it is sensitive. So with the Bayesian, federated learning, you can overcome that problem, because in a federated learning setting, the model, in our case Bayesian network, but can be any AI model, goes around the infrastructure from one station to the other and learns from the data that is available for that model on that data station. So the data never leaves the data station or the data source of the data owner. So in that way, it develops itself and becomes smarter. In this demonstration, which was published by Gavai et al. In 2023, it was demonstrated for 3 data stations, but you cannot, at the same time, you can do hundreds if you want. So the most work in developing, setting up such infrastructure is alignment of the data owners, because you have to get to an agreement about the data owners, what data do they want to share, not share in the sense, but want to make available for the model in these settings. When that agreement is made and everyone agrees, and also they are interested in a model that is developed in this way because they use it for their own purpose, then everything is done by the computers. The algorithm move and travel by itself, and every time, so you don't have to press a button, and every time it gets smarter and smarter when new data becomes available on which it can learn. Just to show you, in this case that has been published, how it can work. So on the left you see station 1, 2, and 3. So these are different data owners who have these stations. And on the second column, you see the flow type. So station 1 has smuggling, mislabeling, organ masking, and substitution dilutions. The years in which they have collected, and a number of cases you see then following. And then for station 2 and station 3, so you see they have different information, different data, amount of data. For example, the data owner of station 1 has nothing about artificial enhancement. That means if he develops a Bayesian network model for the prediction of food fraud type, he never can predict anything related to artificial enhancement or improvement because he has no information there, and the Bayesian network has not that information. So the outcome is shown in this summary slide of this framework. On the left, you see a couple of characteristics that shows the quality of the prediction of the Bayesian network that has been generated in this way. And then you see station 1, 2, and 3 having individual or combined figure. The individual one is the performance of the Bayesian network developed by with the data of its own, and the other one is the combined Bayesian network. Roughly, you can see that the outcome of the Bayesian network via further learning often perform similar, or sometimes a little bit better, or sometimes a little bit lower, but the prediction performance is good. The combined, you should remember, which you cannot see in these figures, that the combined Bayesian network contains more knowledge, allowing all data owners to make better decisions. What I told you, that is the owner of station 1 has no information about artificial contaminations, enhancement. So, but now he has, and now he can make this prediction for his own samples as well. And now I'd like to make some conclusions, which I hope what you can maybe use for an inspiration. The Bayesian network models integrate, I hope I showed you and convinced you that can integrate diverse drivers of change in the food safety and food fraud. They can handle both quantitative and qualitative data, highly efficient, including also data gaps. And last but not least, they are very handy in scenario analysis for testing mitigation strategies. Then overall conclusion related to federated learning. Federated learning infrastructures enhance prediction models in the supply chain. I showed it for the food fraud type prediction. Federated learning addresses GDPR compliance and business sensitivity by maintaining data ownership within the respective database. And finally, in summary, I think that implementation of digital tools, of which I've shown you a couple of examples, can combat food safety increasingly, and this is stimulated by the new opportunities provided by big data technologies and artificial intelligence. And you see, if you look at the literature the last couple of years, at least even last year, a lot of publications appears with new AI models that are highly successful in prediction or combining different data sources and for the prediction of food safety risks. So this was only if you are interested to contact me. This is the last slide. You can contact me through hans.marvin@higengroup.nl, and I thank you very much for your attention.
Thank you so much, Hans, for your insightful presentation. We will move on now to our second speaker, Dr. Yvonne Pfeifer. Please go ahead and share your slides. In the meantime, I will give your presentation. Dr. Pfeifer is a specialist in the application of advanced digital technologies in food safety with a strong focus on AI and regulatory intelligence. At SGS, she works on SGS DG Comply, an AI-powered platform designed to support faster detection, analysis, and prevention of food safety risk globally. She currently works as a business development manager at SGS, specializing in innovation food safety solutions for the food industry. Yvonne, thank you so much for being with us today, and the floor is yours.
Thank you very much, and thank you very much also for the invitation to being here. I would like to show you a bit what we are doing using AI in food safety. So we are focusing mostly on early warning and horizon scanning. And to give you a bit of understanding, where we see also challenges today is, for example, if we are looking at the government-reported food safety incidents in the last years, then we see that these food safety incidents are growing exponentially. In 2024, we have confirmed a plus of 30% more incidents than in 2023, and by October 2025, this number has already surpassed 2024's total by 17%. If we are looking a bit more in the types of incidents, then we found out that the control measures account around about 65%, recalls 27%, and outbreak around about 5%, and with recalls and outbreaks carrying the highest financial and reputational risk for global food companies. So when we are looking in the industry, we see two main different challenges. On the one hand, we have the increasing regulatory complexity and fragmentation, and on the other hand, the limited transparency in global supply chains, meaning we have an operational impact and causing cost to recalls, extended time to market, reputational damage, and also we see the competitive disadvantages. And I would like to show you how AI and large language models could change the game here, or are changing the game here. And I would like briefly to explain what are large language models. It's an AI system trained on massive amount of text data. So text data from multiple sources, then you are processing and your output is clear insights and understood data. And also it gives you a good summary of the information and identification relationships between the concepts. So if we are focusing on food safety, we have millions of chaotic data points. We have the governmental regulations. We have scientific research papers, incidents, reports, and alerts. We have industry standards. We could use news and media and several other data types. And then you give this data in a structured knowledge base. It's an organized data architecture, cross-reference information, and real-time updates. And then what the AI does is it extracts the relevant information for you, analyzes pattern and trends, identifies compliance risks, generates actionable insights, and answers complex queries. And this is when you compare the, let's say, traditional approach with the AI approach, and we have in the traditional manual process, we have large teams manually reviewing documents. You have fragmented information across the sources. You have delayed updates and alerts, limited search capabilities, hours to find relevant information. And of course, we have a high risk of missing critical updates. Now, when we are using, let's say, the more fancy AI-powered approach, then the AI processes millions of documents automatically. We have unified cross-reference knowledge base, real-time monitoring and alerts, natural language queries, instant answers with consent and proactive risk identification. And of course, the impact is really high. You get more speed in your process from hours to seconds. You have more accuracy. you have a wider coverage, and of course you are using the intelligence to get proactive insights so that the result is you can make faster decisions, reduce risk and significant cost saving. And of course, this is not the future, this is the present, this is what we are doing at SGS DigiComply. So we are founded in 2016, acquired by SGS 2017, and today we are a core platform trusted by leading food companies to monitor risks, stay compliant, and enter markets faster. And what do we have? We call us as an all-in-one food safety and regulatory compliance platform. So we have a collaborative AI platform providing real-time monitoring, predictive risk management, and regulatory compliance. And how do we do that? So we are scanning and analyzing millions of sources. So we are collecting the regulations globally. Everything is translated into English so that you can search in English. We are collecting the incidents globally. We have scientific articles in our database, and we are also track social news, meaning by NGOs, by NGO influencers, because this is sometimes also impacting your processes. So we see really that we go from raw data to a structured knowledge base. The data is enriched, classified, and delivered through intelligence records, dashboards, predictive insights, so that it's really easy for you to get the information that you will need to answer the question for you. We have also working with a lot of companies that trust in us. And I also would like to show you a few outcomes of our research project. So we are a partner from EFRA. EFRA is an EU-funded project that will develop the first analytics-enabled green data space for AI-enabled food risk prevention. And I just briefly want to touch, let's say, our use case where we are involved. And this use case is informing regulatory decisions with food risk intelligence. So again, here we have lots of regulatory documents globally, and it's really hard to follow everything, especially when I'm not a regulatory expert for the markets. And here we are using the AI processing to summarization and analysis. Then you have an interactive chatbot and get your informed decisions. And how this looks like is you have a structured data set structured by market, and then you can use the AI Copilot to ask the question that you would like to answer, and the AI Copilot generates the answer, let's say, only out of this subset of data, so that, and you get also the references in here, so that you really can be sure that this answer that you will get is correct. And of course, this is then really time saving for you, because you don't have to go to all these pages of regulations and extract your knowledge. And the last thing that I would like to show you today are two key platform capabilities from our side. So I would like to start with the Food Safety Intelligence Hub. As I mentioned before, we have to handle with lots of alerts and reports globally. And what the Food Safety Intelligence does, it transforms the global food safety data into real-time insight and early warnings, so that you here again can prevent costly recalls, eliminate blind spots in supply chain, detect fraud before it impacts brand reputation, reduce risk exposure, make faster and smarter decisions. And how this looks like, you will get intuitive dashboards creating to your needs with the top hazard ranking and also the market or regions. And I would like to give you a few examples or use cases where you could use this. For example, there's a detection of a new adulterant in a key product, or you see a spike in incidents linked to a specific supplier or region, NGO or media reports on your product or ingredient. Maybe you have a new contamination pathways between ingredients and hazards, or early signs of supply chain fraud. So these are different things that you could answer with the Food Safety Intelligence. The second one is how we are doing the horizon scanning in SGS DigiComply. So trends shift quietly until they don't. So one day it's a rumor, the next day there's a regulation, and then you will have a global recall. And sometimes this could happen quite fast. And I would like to showcase just the ethylene oxide example. I think you maybe you remember all this topic. We had lots of recalls in the last years. And we have also a study with one of our PhD students and a few publications related to this, where we found out that you could have known this earlier if you would have looked into the data. And of course, it's easy to look back and then to find something, what happens. But we would like to use also this knowledge in the future to take the, let's say, the unknown unknowns. And I really could, would like, if you would like to know more about this topic, I can share also the publication with you. This was really quite interesting. So yeah, what we are doing with the Horizon scanning is that we are combining different data types, the alerts and recalls, but also industry trends, regulatory shifts, and scientific publications to give you a holistic overview about the different topics, so that you really can create from the early warnings clear insights so that it's easy for you to follow. And again, here you can monitor thousands of sources, and here the AI helps you to extract only the knowledge for your needs, so that, and again, here you can interact with the AI Copilot so that you don't have to read everything. You can ask the question that you have in mind, and the system will generate the answer for you. And a few use cases that we see for the Horizon scanning, I mentioned it briefly, is the ethylene oxide topic, but we also have titanium dioxide toxicity detected in 2019, and the EU banned this in 2022. And here also some other topics. If you are interested in one of these, just let me know, and we can talk about this. Okay, and then this is what I would like to present today. Thank you for your attention, and I think now we are happy to answer questions. And if you have any other questions after this meeting, I'm happy to connect with you. Thank you very much.
Thank you so much, Yvonne, for your insightful presentation. We go to the questions then now. Please feel free to ask your questions. In the meantime, we check here. I have the first question for Yvonne, saying how the LLM, especially that you are using in DigiComply, was validated. How basically how you can say that it was working perfectly for your case or for your questions.
This is a good question, and I have to say I'm not the expert in that. So I know that we have a process of validation for sure, but this would be something I have to answer with my team.
Thank you. Then the next question is for Hans. Can you share with us, let's say, something to take away in food safety, basically using AI? What are the key steps, or the key step, even if it's one, that can help us to build really a very good AI model in food safety, based on your experience?
Data. Availability of data. Many of these, I guess, also from Yvonne, I guess a lot of that data is, of course, internal data, maybe that you can use, but also open source available data. But there are much more around. I mean, and these technologies we have at the moment can handle these huge amount of diverse data. And the more you have, the better the models can come, and maybe the better the predictions and the future predictions can be made. So, but sharing the data is a challenge, especially if you have paid a lot of money for it and it is sensitive and so on. But there are with this federated, that's why I wanted to address a little bit about the federated learning, because here you can, there's also the imbalance. Often you have imbalance in the different actors, like a farmer. compared to a big company, for example, if the farmer has interesting data, how to balance that with the interest of the big factory producing food who wants to use that data. And with the federated learning, you can also build in a kind of a payment model so that every time the data of a farmer is used, the farmer receives money. Or in other, because farmer may not be interested in the model that is generated from his data. So there's a lot of possibilities over there in order to open up this data from these different data owners that are sensitive and or have an economic impact. So data and data sharing, I think, is key.
Thank you so much, Hans. Then another question to you, Yvonne. How was the regulatory chatbot that you mentioned that was developed in EFRA project was working, basically? Can you tell us more, but not just what can you tell us more about it, how it works, how it was built?
So yeah, we created it really for the use case that we see, okay, if you're using, let's say, ChatGPT or something like this, then you get, of course, a lot of wrong answers. And this is actually, it's getting better, but of course, it's you cannot really trust for this. And that's the reason why we decided to start working with a defined subset of data and only asking the questions to this trusted data, right? So that then if you get then the answer and you have also the references and go to the text and can read also where the answer was generated from, that you are clear this is a correct answer. And this is how this is working.
Had you, let's say, lawyers or experts involved on that?
Sorry?
Had you lawyers or expert in regulation?
Yeah, of course. We have entity comply. We have a customer success team which is who's specialized on the different markets, and we can also use our SGS network where we have, of course, a lot of regulatory experts.
Thank you. I see Saeed has he wants to request generally. Wait, I need to give you permission to ask the question yourself. Allow camera for him as well. Saeed Al-Hakawi, please go ahead. I just see his hand is up. Waiting for you, then I can ask the first question. Another one. This one I think is for Hans. Thank you so much. I cannot unmute myself. Okay, I see. Let me do it. I don't think you have a permission, Saeed. Then please, can you ask your question with the chat? In the meantime, waiting for Saeed's question, we go to another question here. Thank you so much for this impactful session. What other models work best for the prediction of food fraud other than BN models? This is, I think, is for you, Hans.
Yeah, I think if I recall correctly, we have tested more than 20 different AI models, the random forest and so on. None of them some were sometimes as good as Bayesian network, but in fact, most of the times in any topic, also in food fraud, the Bayesian network outperformed. And also Bayesian network has these advantages of scenario analysis as well. But on each, so we have tested more than 20 different AI models, and they were not as good as Bayesian network, or sometimes equally, but then it has more disadvantages than the Bayesian network itself has.
Thank you, Hans. Yvonne, another question for you here. What is the future basically on horizon scanning and the application of AI in food safety, basically with your tool? What are your next steps, in other words?
Yeah, of course, we are working on the integration of more and more using AI applications in the system. So we started using the AI copilot in the regulatory documents and insights, so on a small subset of data. But of course, we would like to go more and more that you get, let's say, really only the important information for you that you need, so that in the future, we will be able to detect the unknown unknowns, right? So actually, it's of course not that easy, but this is our vision where we would like to go.
Excellent. And then I get the question of Said. He's from Max Rubner Institute. He says, I think the question is for Hans here. When we talk about AI in food safety, should we always choose the model with the highest performance, like accuracy, or is model interpretability more important? If we cannot clearly explain how the model works or why it makes certain decisions, it becomes difficult to justify its use to in the regulation level more or in a legal context.
Yeah, that's explainability of the model is obviously very relevant. I mean, the chatbot or ChatGPT, for example, if you use large language models, if you have no control about the data that it can use, then it can hallucinate more. And then if you just blindly trust the outcome, then of course you make wrong decisions. So the accuracy is important, but explainability of interpretability of the output or how it works or how it functions should be clear, at least for the AI specialists. And there should be interaction about the user and the specialist of what is really required by the expert, by the user, so that it works in a proper way. Yes, for sure. And it should always be highly validated. So each model that you will trust and use should be highly validated for its correctness and how it works. So, I mean, for me, maybe Bayesian networks is a black box because I don't understand the technology behind it. I'm more or less no, I mean, so sometimes the technology is difficult to understand if you're not a specialist, but it should be explainable. Yes.
Explainable, and maybe also I would like to add, if we are talking about regulatory texts, what we giving our users is not an interpretation of the text, right? It's really just to extract the knowledge, and then you of course need the regulatory expert who then goes there and doing this, so the interpretation of this content, because I think this is also important to say that it's just to help, as it helps you to find the pieces of information in this document, and then the expert has to do the interpretation.
Yvonne, because you have more interactions with the, let's say, stakeholders in the chain, basically, do you get this kind of question saying, hey, I want to understand the model behind your system, how you are extracting this information, how it works, the validations?
We are working, as you have seen, with large companies, and of course, with the people that we are working with, they don't ask this because then we are just more focusing on the use cases. But of course, we have also, before we start working, exchange with the IT departments from their side, so that they understand, okay, what we are using, that the data are safe, and so on and so forth.
Excellent. Any other questions from the audience? Just he's thanking us, so thanks Hans, and thanks Yvonne for the feedback, for answering the questions. Again, our two speakers, thank you so much. For all the participants participating on this first webinar, thank you so much.